there's a queue outside, but hopefully you're going to get some value out of this as well. What I'd like to talk about is how a product I'm building at the moment with some friends ended up saving about 2/3 of hosting costs by moving to AWS Lambda. I think, do I need to explain what Lambda is? People pretty much know what it is. Does anybody not know what Lambda does? Good, so we can skip that part. For me, the technical side of Lambda that everybody talks about is not at all that interesting, because it's the financial side of things that really makes it revolutionary. And I think over the next maybe 5 to 10 years, pretty much everything that goes into the cloud will go on one of platforms like Lambda. And that's why I think it's really useful to start thinking about these things now. And even if your current app has no way of getting into Lambda at the moment, think about the next one that you're doing, and that's where potentially you can start doing this. And there's a couple of things that are really interesting for me and where we got a lot of benefits out of Lambda for MindMup. MindMup is a collaboration tool, and we have about 450,000 active users a month now. So it's not, the Amazon scale, but it's not a Mickey Mouse thing as well. And we used to be running everything on Heroku up until last year, February, where I had a really cool business idea. And I wanted to integrate the whole collaboration with Wikidata search. Wikidata is a connected graph of knowledge. And the colleague I'm working with said that's a rubbish idea. It's the worst possible idea in the world, and we're not going to do that. And I wanted to prove him wrong, but the way to prove him wrong was basically to just go ahead and do it in secret and deploy it on production. Now, the problem with doing something like that on Heroku is you really have to have a copy of production, because it's an experiment. I don't know whether it's going to work out or not. And he was quite keen on that not being in the main production. And I realized that, well, if I build the rest of it in Lambda, the thing that I don't really want to run everywhere, and then I can figure out how to reroute certain things and not do it as complete copy. And I did that over a weekend. And Monday morning, I started collecting the data, and for a week I collected the data, and actually it turns out it's a rubbish idea. And he was right. And then I deleted this Lambda thing, and everything went back to normal. And, fair enough, had a stupid idea, but it's not the end of the world. And what would have normally happened, cases like that, is I'd already integrate the code, deploy it, and it would be really difficult to pull out. Because of the way that we were designing apps for the last 20 years is we were constrained by reserved capacity. Once you reserve capacity for something, you have to use it, and everything leads people to bundle things together. I used to work, 15 years ago with a big gambling company, and we deployed stuff on immortal hardware. It was never supposed to die. Everything was doubled, tripled, not like British Airways shit. It's proper stuff. And even then, because it was so expensive, if you wanted to do something quick, if you wanted to do an experiment, you were not allowed to breathe next to that machine. So it took a long time to get anything deployed. Everything had to be properly secured, bundled, and things like that. And I think over the last 10 years, we got virtual machines that are a lot cheaper to deploy. We got application level stuff like Google App Engine and Heroku, but still, because we were paying for reserved capacity, if you want to do something simple, you have to bundle it in with the rest of the stuff where it can damage everything. So for MindMup, for example, we support export into about, 20 formats maybe. And some of those formats are used very frequently, like PDF. Some of them, like Markdown, I'm the only person using it. I wrote it for myself. I probably runs once every 3 days. But if we wanted to properly isolate all that stuff, then maybe for PDF we need 5 virtual machines, for SVG we need 2, but then let's have 1 more just for failover. For some other things we need this, for some other things we need that. With proper isolation, I'd be paying for 100 virtual machines, where really I need the capacity of 5. This is my money, so I'm not going to pay Heroku 20 times more. And then we bundled everything into a single app that can scale nicely, that we can secure nicely, but then we forgot to clean up after kind of SVG. And over time, it filled up the Linux temp space. Now, Linux starts misbehaving really badly when it goes out of temp space. So the primary thing died, then the secondary thing died as well, and it was a domino effect where all of those things died. And then I realized that we talk about all these things like solid, like isolation, like microservices, but then bundle everything into an app so we can kind of pay less, and then it starts messing with each other. So the really, really kind of thought-provoking thing for me when we did this Lambda experiment was that Lambda is actually billing for actual usage, not reserved capacity, which means that it starts removing all these constraints around, well, do I need to have 50 machines or 5 machines or 1 machine if I'm going to kind of split my users into 2 different places? How am I going to plan for capacity and things like that? And for us, for the whole kind of experiment with Wikidata is, well, the actual usage of Wikidata is going to be maybe 20 users today. I don't have to reserve a whole copy of production to run 20 users. I'm going to pay for what 20 users actually use. And that opens up some really, really interesting options around how we divide stuff, how we organize stuff. For example, one of the biggest problems we traditionally had designing apps is experimenting with small features, because, again, we need to bundle everything. But also, if you think about, well, it's really, really useful to know if something is going to make money or not. There's a famous episode from Google called 41 Shades of Blue. I strongly suggest everybody kind of Googles, where one of the key people kind of responsible for design wanted to change the color of the links on the Google homepage. And that night, developers wanted to prove him wrong, so they did 41 different shades of blue. And kind of they proved that his color would kind of lose something like $250 million a year. Now, 10 years ago, companies like Google were able to do that. Companies like Facebook were able to do it because they have lots of this stuff. They can run they can run 41 different copies of their production. For me, that was kind of out of reach. With Lambda, that kind of is not just in reach, but it costs exactly the same as running a single copy. If I have 400,000 users and I split them into 2 groups, 2 different versions of the app, it costs the same as keeping everybody on the same app. It's per usage, not reserved capacity, which opens up some really, really interesting kind of options there for smaller companies. I have some friends in Australia, and they're continuously complaining how Facebook is broken in Australia all the time, because apparently they're experimenting with business features there. It's a market that's big enough to be statistically relevant, but not as important as the US in terms of money. So they'll kind of roll out broken features there, iterate, and then when it's done, release to the US. Now, again, 10 years ago, you'd have to be Google or Amazon to do stuff like that. Now, if you're a 2-person company, that's perfectly fine. And that's really, really interesting from a perspective of kind of everybody's talking about A/B testing, but A/B testing is mostly limited to front end. Imagine if you could do A/B testing back to back on your app, experimenting with features, and it doesn't cost you anything. And that's kind of the really, really interesting part of kind of going to pay for actual usage, not reserved capacity. Now, the second thing that's really, really interesting here, and maybe Amazon has kind of done this by mistake, maybe not, but it's a really interesting business opportunity for people like me, is kind of what Lambda is billing for is time and money. Time and memory. You pay, I mean, there's some kind of 0, blah, 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 0 something per 100 milliseconds, and you reserve the amount of memory you want to have there for those 100 milliseconds, which means that you can play arbitrage Amazon against Amazon with services that do not charge for time or active memory. For example, S3 doesn't charge for time. S3 charges for storage capacity, where kind of IoT gateway charges per message. And things like that are really, really interesting opportunities to kind of save money. One of the ways we used to work is kind of with Heroku, you upload the file for conversion by sending it to the server. The server is the gateway, the server is the gatekeeper, the server is the part of your application that validates everything the user does, and then after that the backend trusts the server. And the thing with something like that is, in order to upload a large file to S3, the server's busy. The server sends the file to S3, then kind of we convert, then the server sends stuff back. The server is basically busy doing file transfer, where what became quite an interesting opportunity here is to use Lambda as a way to kind of plug in the holes between the platform offering and offload the pricing to a completely different thing. For example, this is kind of a simplified code example of what we do, but it's enough to show you what I want to show you. Is this font big enough? Okay, good. So kind of here I have a Lambda function that kind of allows people to upload the file. But what it does is it doesn't act as kind of an endpoint for uploading a file. All it's going to do is fill in some parameters, like you're only allowed to upload to this URL. And I could have done something more. For MindMup, we limit people by the maximum file size, the MIME type, and a ton of other things. But then you do this kind of magical thing here that basically creates a pre-signed request for S3. What that means is basically we have a very, very quick request going to Lambda, give me a signature. Then the browser can spend time uploading gigabytes and gigabytes to S3, for which kind of I'm paying for transfer. I'm not paying for time, I'm not paying for processing. And then a completely different Lambda can wake up and execute on it. And the thing why this is really, really kind of where we saved a ton of money is, for example, if you want to upload, I don't know, 10 megabytes, you need to keep quite a big Lambda there. If you want to get somebody to upload 100 megabytes, you need to pay a lot for memory because Lambda gets the whole request in line. Where if we now offload this and get S3 to handle the upload, we can wake up a Lambda that does streaming. Works much, much better on smaller files. We pay for less memory. So anything that doesn't charge for active memory or kind of processing time is quite a nice opportunity to offload and arbitrage costs. And one kind of, as a kind of, let's run this stuff. So, yep. So this is kind of now going to Lambda, and it's going to create a very simplistic web page that is actually kind of going to return an HTML form. And once I kind of, this is done, so I have a URL. And it's on the upload file. So if I do upload file, come on, okay. We have a very simplistic form. I choose a file, that's this thing. I can now upload it up. And it's going directly to an S3 bucket. So, you know, I could have uploaded something that's 10 gigabytes, but, you know, we need to get to beer. And now I can basically do, this is the CT upload test. And there's my file. So, kind of, from this perspective, there's a big difference how the traditional kind of web app development works, where we are no longer using a gatekeeper to kind of validate the client requests. We are using a gatekeeper to sign a request and then let it kind of talk to Lambda, let it talk to other resources. And I think that's quite interesting because more and more we are moving to this model where we're letting the client talk to end resources directly. For 20 years of developing server apps, my brain is telling me don't let the clients talk to storage. Don't let the clients talk to storage. That's kind of, in my head. But then I realized, well, there's no backend resources anymore. S3 is available on HTTP. Dynamo is available on HTTP as well. It's all on the front end. The fact that, people have hidden the URL there doesn't mean it's not accessible. And Amazon doesn't trust a request to S3 any more or less if it comes from Lambda or if it comes from a browser. It's all about kind of providing the right level of authentication. So there's some really, really interesting stuff we're experimenting with at the moment, and this is not fully complete, but it's a demo you can look at online now. And this is kind of abusing the IoT gateway. And again, kind of now Danilo is here, he can tell people how I'm abusing it at AWS and they'll shut it down. But IoT gateway is a really interesting service designed for low-power devices to talk to each other. And they have also implemented a WebSocket interface, which means browsers can connect to directly. So we're now kind of experimenting with real-time collaboration where we're going to go through the IoT gateway because browsers can connect to directly. And this whole code is published on GitHub. It's about 30 lines of code. All it does is you get an authorization to connect to the end queues directly. And again, for 20 years of kind of server development, my brain is telling me, don't let the clients connect to queues. Don't let the clients connect to queues. But then, again, your request is not trusted any more or less if it comes from Lambda or a browser. And then if you go to this URL, serverless chat, so, we should all be able to connect now. I mean, should handle a couple of hundred connections easily. And you log in as a guest, you basically, that's the signature part. You get a unique authorization ID, you join a chat channel, and now we can talk about. So, yeah, we have a massively scalable chat built in 20 lines of code that's basically just doing the signature so the browser can connect to a backend resource. And if, of course, we wanted to get something to do some sensible processing, domain-specific processing, I can do a Lambda that does this at the end. And this is the really interesting part of Lambda for me is moving more and more to Lambda. And it took us about a year to kind of transition all the services. We realized that all that's left is kind of domain-specific code. All the infrastructure code around connecting to queues, managing queues, and things like that, that's all gone. Kind of the clients can connect to a backend resource anymore. There is no backend resource anymore. It's all on the front end. And that's the really, really kind of mind-blowing thing for me. So yeah, you can get this thing from GitHub if you want. So kind of going back to what's really, really interesting for me is at the point where you no longer have to pay for instances, you no longer have to pay for file size, to pay for kind of number of messages in the processing thing, it becomes really interesting to see what other services you're using and can you reduce your cost significantly by letting the clients directly connect there. IoT Gateway, I'm probably lying to you now, I don't know exactly, but it's something like $5 per million messages. And I said, if we wanted to do some kind of smart replies or something like that, then you actually do the code that's missing. So kind of from that perspective, there's the biggest lesson we learned over a year of transitioning to Lambda is kind of that to get the benefits, really, we can't use it as a web hosting tool. There are libraries out there, like there's a Spring Boot library that allows you to take a Java app and pretty much deploy it in Lambda. There's the AWS published an Express gateway that allows you to take an Express web app and put it into Lambda, but then kind of that's only using Lambda as a web host. And then you'll probably end up paying 5 times more than just keeping it on a virtual machine. But by embracing the platform, rather than just using the Lambda as a service, we've been able to kind of reduce our costs by 2/3 by kind of moving what we pay for. Plus, we removed one of the biggest bottlenecks. So what I mean by that is the platform actually gets the traditional server roles. The gateway that everything trusts, that's the platform. That's kind of either using IAM for authentication or Cognito or signing requests and using SIGV for, there's, Amazon being Amazon, there's 3 different ways of doing everything. But there's lots of options there. So kind of the distributed authentication is really kind of, it's difficult to get, but it's really well done. And it allows you to say, allow a particular browser client to only write to a particular type of file, a particular prefix. So you limit what people can do. We still are not allowing people to talk to Dynamo directly because my brain is telling me, don't allow the browsers to talk to database, don't allow the browsers to talk to database. But I know in Daniel's book, there's kind of a Cognito example where you allow people to write with the prefix for their own kind of account ID, so you can't really damage the data that doesn't belong to you. So the other thing that kind of we've learned, especially a year and a half ago, there was lots of talk about how you need to do these periodic things to keep Lambda warm because Lambda is kind of slow to start and things like that. Pretty much, I think it's either been improved significantly or we've not really had those problems. But we have some really good end-user metrics to see how, what people's latency is. And moving from Heroku to Lambda, we kind of didn't notice any big differences. So kind of for 20 years, one of my biggest skills was good capacity planning. And like, truck drivers or taxi drivers, robots are going to replace me. And, Amazon probably has much better algorithms for capacity planning than I can do anyway. So we've just learned to trust the scaling thing. It's not ideal, but hey, it works. And the last really, really interesting thing that kind of opens up as an opportunity is if you start letting clients talk to backend resources directly, you can push the workflow to the clients, which means that your app is not running on 100 VMs. Your app is running on 400,000 client processors, and you're not paying anything for it. You're not paying for coordination, not anything, but you're not paying for coordination, not paying for orchestration. So kind of the key reason why we've been building orchestration into servers for 20 years or 30 years is because we couldn't trust the requests. So, and now that we don't trust anything anyway, there's no reason not to push coordination outside. So any kind of infrastructure coordination, stuff like that, really is not where the core value is. And that's why I mentioned kind of our Lambdas are now really just what's domain specific for our app, and we keep it there. So kind of as a quick summary, here's the stuff we discovered as interesting in terms of the strengths of the platform. First of all, the time to deploy really becomes minimal. You've seen I've deployed a new Lambda function. It took me less than a minute. Fair enough, the code is relatively simplistic, but hey, giving a good network, it's not going to take much longer. So things like running a quick experiment, setting up something that you can play around with, or coming up with a new version of an API and kind of deploying it there is really no longer that important. In 2007, I worked with one of the kind of largest telecoms companies where it took us 2 months to develop the app, and then it took them 7 months to provision the machine to run it. Where we're getting to the point where it takes less than a minute to spin up a new version of the app. The other thing that's really, really interesting is kind of time to recover as a constraint with Lambda is almost becoming irrelevant. Amazon doesn't really publish any official data, or I don't know any official data published around this, but my experiments tell me that kind of it takes around 1 second or 2 seconds to spin up a new instance when it needs to spin up a new instance for JavaScript. I think for Java it's kind of a slightly longer, but we're getting to the point where one of the key constraints that's kind of held architecture as a kind of something that's given for 20 years, that's time to recover, is no longer an important constraint. Like the whole thing about blue-green deployments, primaries and failovers, everything we've kind of been taught to do as best practices is no longer that important because this constraint is being removed. Kind of the multi-versioning for us is one of the biggest advantages here. Being able to quickly run multiple versions of the same code, of the same API, and then send 10% of people here or 20% of people there, or run a special version of the code for London, or run a special version of the code for a particular client is really, really mind-blowing because we're no longer kind of constrained by reserved capacity. I don't know how many times I've been in a situation where we work with, 20 clients, one of them really, really needs some business feature, and it's one day to develop that, but then if we want to make it consistent and deploy across all our clients, we need 2 more months to kind of properly test it. Where with something like this, we can spin up a new version for that particular client, and then over time kind of properly test it, so time to market shortens quite significantly. Plus, I mentioned this allows us to do A/B testing properly back to back. With a company of 2 people, I'm not Facebook and I can do this, which is amazing. So I can annoy Australia all over again, that's, you know. So kind of the next thing that we started realizing is that the more we were taking infrastructure out, the more kind of our code modules became smaller and better isolated. We're getting to the point where I think we've rewritten the PDF exporter about 3 times after moving to Lambda, and we use different technologies. Pretty much we just throw the old thing away, it's 200 lines, and we write it from scratch. We keep the knowledge, we kind of write it from scratch. And that's one of those kind of really interesting things where when everything is bundled, you're afraid of throwing away a piece of code. You don't know what else is kind of influenced by that, but when I know that this is kind of a 200-line isolated module, I can just kind of, you know, throw it in and kind of write something from scratch. And another thing that's kind of really, really interesting is, you know, Amazon at the end of the day has to charge you something for this. So they have to report how much you've spent on each particular function. And that means that this thing opens up an opportunity for proper optimization. I don't know how many times, oh, you know, this is running slow or it's expensive. Well, I know how much money this particular thingy makes and how much it spends. And I can decide if it's worth optimizing or, you know, do we just throw it away? Or, oh, it's slow. Well, you know, how slow is slow? That particular thingy, not everything else around it. And this whole side effect of having this transparent micro-level costing and micro-level reporting how long something took to run is really, really amazing. I know that kind of this whole X-ray thing was released, and I'm not really experimented with it yet. But that's certainly something interesting to investigate in terms of figuring out how these things fit together. But I think kind of the low-level costing and optimization possibilities are, you know, I've never seen something like that before. So kind of in terms of the threats that I see really here as a potential thing to, you know, be concerned about if you're thinking of doing Lambda is the first thing is lots of companies have woken up and understood that kind of they're now competing with Amazon. I did that talk at kind of messaging company 3 weeks ago where they were talking about how they're going to kind of build up the whole replication and streaming and how much, you know, they're going to invest in doing these things. But if you think about embracing the platform, all these things pretty much already exist on AWS. And I know there were a couple of comments from reInvent where kind of lots of people went into reInvent expecting that they're Amazon partners and woke up to understand that they're now their competitors because Amazon is launching a new service every day and there's now kind of business intelligence, there's data warehousing, there's a ton of other stuff. And the really interesting kind of part then becomes is where do you provide your kind of value? And again, from the thing I mentioned earlier, after you take out the platform away, kind of the stuff that remains in the code is your unique domain-specific thing. So that's what's left in Lambdas. And kind of the, I think especially moving to a position where clients connect directly to resources and you do some domain-specific processing based on the different things, there's a horrible opportunity for platform lock-in. And I don't mean code. Everybody's talking about how there's no code lock-in because you don't depend on Lambda, Lambda depends on you, and things like that. But with this whole idea, you let clients connect to stuff, you design your app basically around how Amazon's distributed auth works. You design your app around the constraints of their way of distributed authorization and their way of distributing stuff that's completely different from how Google stuff works. So even if the code doesn't depend on that, at this point, if we decided to move MindMup to Google Cloud, I kind of guess will be months of retesting, rewriting, and things like that. And kind of, how am I doing with time? Have I overrun? Okay. So kind of, there's a couple of weaknesses I think that are interesting, and this is where, you know, the platform is changing so quickly that maybe, you know, Jeff Barr already announced that all these stuff are obsolete as I'm doing the talk, but if you're thinking about experimenting with Lambda, there's a couple of things that kind of you can't do yet. I expect it to be resolved in a few years. The first thing is there are no SLAs on anything yet. And, or at least no kind of published numbers. Our data, according to kind of how much our stuff worked, is kind of around 99.9. Which is, again, not official. It's our use case. It's not something that, might happen to you. And again, with the whole multi-tenant thing, maybe different people get affected differently. So in terms of kind of that's okay for our use case. It might not be okay for kind of what you need to do. And kind of, again, the nice thing about this is if you let clients directly connect to backend resources, you don't care that much about the Lambda SLAs. S3 SLAs, IoT gateway SLAs are slightly more important, or they kind of alleviate that problem. The other thing is, at the moment, the thing looks to me like it's designed for throughput, not latency. What I mean by that is, if we have 50,000 people on the system and then another 50,000 people come, this thing will magically handle it. Everybody will have the same kind of latency. But again, Amazon doesn't publish official data, or I don't know there's any official data on this, but our end user metrics from England and from the US are that browser to API gateway to Lambda all the way back is 100 to kind of 250 milliseconds. And you just can't get it below that. So it's not really good for, I don't know, 10 millisecond network level processing. Of course, you get people to connect again to queues, you get SNS, you get other things, but even with that, we have Lambdas firing off from SNS and things like that. That's about 50, 60 milliseconds. So, and it's not guaranteed. There's no guarantee that everything is going to be below 60 milliseconds. As I said, a new instance takes a few seconds to spin up, so a couple of your users might get more than 2 seconds. And there's no guarantees on this yet, and I think that's going to be interesting to see how the platform evolves because it's limiting kind of use cases. There's no compliance on anything yet, or at least I've not found it. We have a couple of hospitals that have woken up to kind of this wanna cry or whatever kind of that we're using us, and now they're asking us for kind of, are we compliant? It's like, I know that kind of if you use EC2, if you use other things on Amazon, you can actually get compliance for lots of things. With Lambda, not at the moment. So you shouldn't really be processing highly sensitive information here. But then again, I assume something that is kind of a bit of bureaucracy that needs to be done at some point. It's not there yet. And at the moment, lots of people get burnt by expecting that they can keep persistent connections. For example, a couple of my colleagues have built like a bot engine for chatbots, and they've integrated Facebook Messenger, Twilio, Viber, Skype. There's a ton of things, and then they want to do Twitter. And the way you integrate with Twitter is you have to kind of hit them open an HTTPS connection, and then they'll stream stuff to you. And Lambda is going to kill it after 5 minutes, because that's the maximum runtime for a task. And then you can kind of do all sorts of magic to restart another Lambda and things like that, but then the connection disappears. So at the moment, there's kind of a limit on how long a task can be, which again, I assume over time is going to get kind of improved. And configuration tends to be a big challenge. Configuration is a bit magical still. There's kind of, you need to know exactly what buttons to push where, and there's several open source tools that have emerged, and Amazon is kind of improving the CloudFormation. I think from my perspective, CloudFormation is definitely going to win in a few years' time, but CloudFormation is too much of a universal software now. I found on GitHub a CloudFormation script that will launch a complete L2 PPVPN that I can use to stream movies when I'm traveling. And it starts with kind of defining the instance, then there's kind of a bash script this big included inside. So it's magic. It's API gateway is universal software. It gateways anything to anything, and there's a lot that needs to be configured for a simple use case. So kind of we've actually open sourced the thing we built to kind of help us deploy. Because the first Lambda I built was something like 40 lines of JavaScript, and it took 200 lines of bash scripts to deploy. And I realized kind of the risk is in the deployment script, not in my code. So we built a tool to unit test deployment. Serverless tends to be the most popular framework these days. I think that the benefit is that they are kind of multi-cloud and things like that. But then again, I think the lock-in is not in the code. The lock-in is how all the stuff around it works. Apex is good for kind of scheduling tasks, running things. And again, I think CloudFormation will win in a few years' time. It's just a question of when. And I know that there's this whole serverless application template that kind of does a lot of stuff already in CloudFormation. But yeah, I was too stupid to use it a year ago. So that's pretty much it for me. Thanks very much for kind of suffering through this. And now I'll let kind of Danilo tell you why all this is wrong.
Wow, that was I really enjoyed that. Thanks very much indeed. Any questions, please? I'm sure you've got one somewhere. Hidden, maybe? No? No? All right, then. Thank you so much. Really appreciate that. Another